We're live.
Hello, everyone. Welcome to this workshop. This is the AI and Machine Learning Essential for Developers workshops. I am Neda Navidi, AI professional researcher at ETS of Montreal, Canada, with more than 15 years of experience in AI and machine learning fields. These days, there are some questions that really bugs us, like, will robots replace human drivers, doctors, and other workers? And the answer is no. While the robots has replaced millions of manufacturing workers, however, still there are lots of place for humans. In fact, automation is getting cheaper and cheaper by robots. However, still there are lots of jobs for human, and we'll talk about it, how really robots can help human for doing the jobs. If we want to compare human with machine can think and work like humans, but free from human errors and biases. It can harness the big data with high computational power. It can run on highly sophisticated algorithms that are the next frontier in technological arms race. And it can also be used in broad investment like as government, universities, startups, and big companies. Well, in fact, machine learning is the intersection of programming, statistics, and data. In fact, the basic problem of machine learning is to explore how computers can program themselves to perform a task and to improve their performance automatically. For example, in email spam detection, a system could get feedback from the user. To accomplish this goal efficiently and effectively, machine learning relies heavily on statistics and computer science. A statistical method gives machine learning algorithms way to infer conclusions from data and to learn from data, and also to estimate how reliable those conclusions are. Computer science methods, on the other hand, give machine learning algorithms the computing power to solve the problems, including effective large-scale computational architectures and algorithms for capturing, manipulating, indexing, combining, and performing predictions with data. Think about how quickly a commercial search engine can match your query against billions of web pages and almost instantly return a set of useful results. There are also growing connections between machine learning and other fields. Those are really fascinating. For example, the problem of how someone or an individual or a system can optimize their performance in a given environment is also shared what research that people have done in biology. It's also connected to research on economics in how optimal pricing and market structure can be computed. Even psychology, especially psychology, where we have a model and factor of human learning. Machine learning algorithms are now involved in more and more aspects of everyday life, from what you read and watch, to how you shop, to who you meet and how you travel. There are lots of machine learning approach and we wanna talk about it in this workshop. For example, machine learning is the method of data analysis that automates the analytical model building using the algorithm that iteratively learn from data. Machine learning allows computer to find hidden insights and mm, as a black box can use those models to do prediction. In fact, machine learning learns how best to achieve a desired output. It processes data in a way that machine can detect and learn from the pattern, predict future activity, and make decisions. On the other hand, data is really a fuel. More data we have, the better learning we can do and the better model at the end we have. One of the important aspects of the machine learning is the measure the data quality. There are 5 R's of data quality: relevancy, recency, range, robustness, and reliability. When we're talking about the relevancy, we really do the question of, is the data collected is relevant to the problem we're trying to solve? For example, if we're trying to model of the driving behavior and our data is not related to that, we cannot train a model with using those data. So the relevancy is one of the one of the most important factors we should consider in the machine learning. The other one is recency. How recent was the data generated? If the data is really old, cannot be used for the training and predict the new model. So it's really important our data generated and created recently, and there are more similarity between the previous data and ongoing data. The other factor is the range. How narrow or wide is the scope of those data? Robustness is the other one, and it's mostly about the noise, signal to noise ratio, how much those data are robust by passing the time. And at the end, the reliability, how accurate is the data that we're trying to work with. Also, we should ask some other question from ourselves, like, what is the target data quality? What if only 50% of the data is available? And how sensitive is analysis to missing the data? What signal will be used to understand the quality of the data? We should understand the comparison between the noise and bias and something like that. When we're talking about the AI, machine learning, and deep learning, most of the people think that the AI and machine learning are the same approach. However, it's not. And we want to first talk about what's the difference between the AI, machine learning, and deep learning. AI, or artificial intelligence, is any computer program that does something smart. It can be a stack of complex statistical model or very simple if-then statement. AI can refer to anything from a computer program like playing chess to voice recognition system like Alexa. However, the technology can be broadly categorized into 3 groups of the narrow AI, general AI, and super intelligent AI. Machine learning is not AI. Machine learning is just a subset of AI. The Theory is simple. Machine learning data and learn from the data, itself, in fact. It is currently the most promising tool in the AI pool of business. Machine learning system can quickly apply knowledge and training from the large data set to excel at facial recognition, speech recognition, object recognition, translation, and many other tasks. Machine learning allows a system to learn to recognize pattern on its own and make prediction. Contrary to hand coding a software program with a specific structure, machine learning can learn from itself. It doesn't need any hard written program for that. The other concept here is the deep learning. Deep learning is a subset of machine learning. Deep artificial neural network are a set of algorithms reaching new level of accuracy for many important problems, such as image recognition, sound recognition, recommender systems, and the other kind of problem that we're trying to solve. It uses some machine learning technique to solve the real world problem by tapping into neural network that simulate the human decision making. Deep learning can be costly and require huge data set to train itself. If we wanna see machine learning workflow, we see there are 5 main steps that are, as you can see, data gathering, data preparation, and manipulation, training the model, testing the data, and improvement. Machine learning is about predictive model building that rely on data collection and data analysis. When we're trying about the data preparation, we are okay. If we wanna see the machine learning workflow, we can see there are 5 main steps that are data gathering, data preparation, and
eu fiz ali que fosse
manipulation.
e vou liberar aqui duas. Espera aí.
Sorry, can you put your mic off, please? Thank you. So as I said before, when we're talking about the machine learning workflow, we can see there are 5 main steps that are data gathering, data preparation, and manipulation, training the model, testing the data, and improvement. Machine learning is about predictive model building that rely on the data collection and data analysis. When we are talking about data pre-processing, we are referring to assigning numerical value to categorical data, handling missing values, normalizing the features, and the other step in machine learning rely on the algorithm selection. What kind of algorithm we will use to optimize the cost function? Model selection is other issue, and it's about parameterized mapping between the data domain and response set, which learns the characteristics of a system from the input or the label data. The learning algorithm is used to train, validate, and test the model using a given data set to find an optimal value for the parameters, validate it, and evaluate its performance. There are two main phases in machine learning: learning phase and prediction phase. In the learning phase, we train a data. We have a data set. We're trying to train a model with using those data sets. So with using a learning algorithm, we can create a model. In fact, we computing and create a model. When we create a model in a prediction phase, we're trying to use the unseen new data and input those kind of data to the model. And at the end, we can do the prediction. So we should understand that in the learning phase, we are trying to use the data that they are totally labeled, and we are know about their concept. We're trying to label them. We're trying to analyze them, parameterize them. We're trying to select a specific kind of algorithm, and with using those algorithms, we train a specific model. Probably we need to tune those models to be sure that is the optimal model. Then after when the model is completely ready, we're using the unseen data. And at the end, we can predict the result with using that model. If we wanna really find the best definition for machine learning, the question is that what defines the field of machine learning precisely? In lots of cases, when a computing problem needs to be solved, for example, storing and retrieving data from a database, the way we often address it is to write a program that manually specifies a series of programming steps that needs to be run to solve that particular problem. This works great for the vast number of computer science problems that are out there. However, not all problems lend themselves to being solved effectively by writing the handcrafted program or set of rules. For example, how would you write down a set of rules in a programming language for accurately converting the human speech to a text? A process known as speech recognition, which is now available on millions of smartphones or used in customer support systems all over the world, with the huge variety of different vocabulary and accents. Writing a set of program rules by hand that could recognize a portion of an audio signal and decide which word were in that script, it would be a huge task. And even then, it would still likely be inflexible and not very robust and recognizing different type of speech. Moreover, if we need to customize the system so it could recognize new words or other features that we haven't encoded in our existing rule, we have to write the whole new set of rules, which would be a difficult task. On the other hand, machine learning gives us a technology that allows us to automatically learn those complex rules efficiently from the labeled example called training data in a way that is much more accurate and flexible than attempting to program all the rules by hand. Moreover, as a primary goal of effective machine learning algorithm is to be able to generalize we can correctly predict or recognize new objects that weren't seen during the training. So the basic problem of machine learning is to explore how computers can program themselves to perform a task and to improve their performance automatically. For example, in email spam detection, a system could get feedback from the user. Another example, a search engine get clicks on a search page, or a system could get data from the surrounding environment that's gathered over the time. And the last example, self-driving cars that can detect nearby objects and events and learn to more and more reliability. These are three main category applications of machine learning that most of people using of them every day, or at least hear about it. About the search engine, mostly you're using every day. About the email spam detection, you're not using it directly. However, when using the Gmail or other email provider, they use it to categorize your email and detect the spam and sending to the spam box. And about the self-driving cars, these days there are lots of drivers that using the machine learning and deep learning can do drive by itself without any driver at all. To accomplish this goal effectively and efficiently, machine learning relies heavily on statistics and computer science. The statistical methods give machine learning algorithms way to infer conclusions from data and to learn from data, and also to estimate how reliable those conclusions are. Computer science methods, on the other hand, give machine learning algorithms the computing power to solve the problem, including effective large-scale computational architectures and algorithms for capturing, manipulating, indexing, and combining data. Thinking about how quickly a commercial search engine can match your query against billions of web pages and almost instantly return a set of useful results. There are also growing connections between machine learning and other fields like as psychology and biology, and dealing with different kind of research related to the human and how a human can act in different kind of environment, like as in driving, in using the search engine and the other things. Machine learning algorithms are now involved in more and more aspects of everyday life, for what you read and watch, to how you shop and who you meet and how you travel. And here is just a few examples. One of our example is the fraud detection. Every time you buy something using a credit card, machine learning algorithm immediately check your purchase to verify whether or not this might be a fraudulent transaction. To do this, these algorithms look at features of current transaction that you have just made, such as time, location, and the amount of money. They make a prediction of whether it's fraudulent or not based on whether that purchase is consistent with the feature of your previous purchases. The system also records any user feedback on whether the transaction was in fact fraudulent. and it uses that feedback to make better prediction in future. Search and recommendation system are also a huge area of application for machine learning. And in fact, those machine learning algorithms are at the heart of how commercial search engines work. Starting with the moment you begin typing in a query, in fact. So one algorithm might monitor your keyboard to predict the best query is the autocomplete while you're typing something with your keyboard. And then once you've finished your query, some other machine learning algorithm would be applied to determine the selection and ranking of the web pages that you see for that query. Still, other machine learning algorithm will determine which ads you see on the page and so forth. In addition, search engines typically use data about how you interact with the search site, such as which page you click, how long you read the page, to improve their features, effectiveness. In a similar way, movie recommendation sites like Netflix and YouTube use machine learning algorithm to model what you like in your past reviews based on your past reviews and your interaction pattern with the site and how your preference related to those of the other users. And it uses this data to learn a model for your personal taste to hopefully give you better choices that keep you more engaged with the site or that lead you to make more movie purchases over the time. And then finally, a third example area that's really seen a significant improvement in the past several years in terms of recognition quality speech and image recognition. So although researchers have been working on speech and image recognition for decades, in fact, recently, the development of increased computing power like GPU and TPUs, better algorithms can be used like deep learning. And vastly increased volume of data have led to a significant jump in accuracy and flexibility of recognition algorithm in the past 5 years. Now, recognition technology is reliable enough and fast enough that it's used as an essential feature for the smartphone and home devices that can act on a spoken command and questions, like as Alexa. Computer vision and image recognition can be increasingly accurate identifications of objects and action in image and video. Even for a while now, over 85% of handwritten mail is sorted automatically with very high accuracy by postal service. There are very exciting advances in the medical domain where the image recognition algorithm are being developed to classify the cancer, to find hard to detect tumors in medical images. And of course, self-driving or autonomous vehicle make extensive use of real-time image recognition and video processing, as well as other such as reinforcement learning. Now, this example only scratch the surface of how machine learning is being applied in today's society, and we'll encounter and work with some other examples during this workshop. According to a forecast by the research company Autonomous Next, banks around the world will be able to reduce costs by 22% by 2030 through using AI techniques and technologies, and saving could be reached out to $1 trillion. Financial companies employ 60% of all professionals who have the skill to create the AI system. It's expected that face recognition technology will be used in different banking sectors to prevent credit card fraud detection. Face recognition technology will increase its annual revenue growth rate by over 20% by 2022. AI and machine learning are able to provide a unique level of automation, either by taking over the task of a human expert or by enhancing their performance while assisting them with routine, repetitive tasks. But what are the main benefits of machine learning? This question has many possible answers. Here is the attempt to highlight the most important one. The first one is greater automation and improved productivity. AI and machine learning can easily handle mundane tasks, allowing manager more time to work on more sophisticated challenges than repetitive paperwork. Automation across the entire organization will ultimately lead to greater profit. The second one is the personalized customer service. Automated solution with big data capabilities can track and store as much information about the customers as needed, providing the most precise and personalized customers experiences. Optimizing the customer footprint allows, in fact, different kind of company like bank to leverage the analytical capabilities of AI and machine learning to detect the customer behavior, which help create a more personalized experience for each individual client. The other one is the more precise risk assessment. Having an accurate digital footprint of each customer also can help companies reduce the uncertainty for manager working with individual client. The automated system is more accurate than a human in such area as analysis of loan underwriting, eliminating and possible human bias. And the last one is the advanced fraud detection and prevention. It's probably the benefit of AI and machine learning for any financial institution, because criminals who are devising methods to commit financial fraud. Fortunately, there are currently a wide range of proven models and methods and techniques of ML-powered fraud detection on the market these days. We will talk about those methods and algorithms later, and we can find out how make them to prevent any to prevent the fraud detection. As you can see in this table, in 1920, several digital attacks hit users here and there, leading to massive data breach and the leakage of vulnerable information. That's not the case to ignore for the financial industry owner and payment services providers who are highly concerned about their customers' loyalty and safety. According to the statistic of the US Federal Trade Commission, fraud reports in 2019 include more than 4,000 cases that result about 2 billion of losses. The data that any financial industry receive from their customer, investor, partners, and contractors is dynamic and can be used for different purposes. Depends on which parameters are used to analyze them. Basically, the scope of AI for financing can be grouped by 5 large groups. The first one is improving the customer experience. When financial industry and organization got the opportunity to learn everything about a user and his behavior in a network, they gained the opportunity to improve the user experience as much as possible. The other one is the chatbots. For example, if a user has difficulty working with a website or application, chatbots are used to lead him along the right path and at the same time reduce the bank support workload. Simple operations such as unlocking and unlocking card, as well as send notification to user if he has exceed the overdraft limit, or if the account balance is higher than usual. The other example is the personalized offers. Having a variety of information about user behavior allows financial companies to find out what customers want at the moment. And moreover, what they are willing and able to pay for. So for example, if a client was looking at ads for a car dealer, then it might make sense to develop a personalized loan offer. Of course, after analyzing his possible risk. The next one is the customer retention. Modern AI system working with big data in financial organization and system can not only analyze, but also can make assumption. For example, in a number of cases, it's possible to predict the intention of the client if he wants to refuse the service of a bank organization. The knowledge of this intention signal that it's necessary to take additional retention measure, create even more target and personalized offer, and as a result, improve the customer experience. The last one is the bank fraud detection. In fact, banking fraud detection is in the first place linked to the detection and prevention of damaging operations that deal with transaction failures, returns, disputes, and money laundering, and the other things. A much safer strategy for every payment service is to set a reliable fraud prevention system rather than deal with consumption of the bad customer experience and fraud losses. We know that fraud prevention solution can be built on an old rule-based approach, which is now uncommon, or analytical based on machine learning and anomaly detection in particular. So what is it about AI that makes the fraud detection and prevention more effective than other methods? The answer is, unlike the purely rule-based software, AI-based solution can smartly drive correlation in fraudulent activity to further detect new fraudulent patterns. Simply writing rules cannot cover the whole diversity of scenarios that can lead a person who trying to attack a system transaction be unnoticed among others. Moreover, it's hard to make these rules accurate enough. Some site that can be give the model a hit on how to tell a good transaction from an illegal one are the following. It's the customer behavior, how he usually makes purchases, his usual location or time. In fact, gathering those kind of information can find the good anomaly detection in the fraud detection process. As stated by the consumer network, customer network, the most serious threat for financial company is the credit or debit card fraud. The median losses of a person out of the yearly fraud losses is around $320,000, which statistically show that the younger people are more exposed to fraud more than people age 30 or older. The most concerning thing about this report is that only 20% of people reported their losses, meaning that most illegal affairs remain in a dark while the victim keep losing the money. So the question is, how much do bank lose to a fraud? Among the types of fraud that are specifically a threat to banking industry are credit and debit card fraud, employment or tax-related fraud, mortgage fraud, government document fraud. Let me talk more about the credit and debit card fraud, because it's one of the most important fraud in financial system. Credit or debit card fraud has been topping the list of types of the fraud in financial companies for a long time. It's that popular because there are numerous ways to secretly get your credit card information. Once access to the card is available, the robber can start using your money. While most other bank fraud types are more sophisticated to perform. Sources from where the robber gets the information are varied to discard the receipt, credit card assessment, any documentation on your bank, on ATM. Credit card fraud is usually detected with machine learning methods such as supervised or unsupervised anomaly detection and classification and regression technology. To train a robust machine learning model to detect the card fraud, the most important aspect is to larger and representative set of fraudulent and good transaction combined with a feature extraction phase performed by a skillful data analyst. There are other fraud like as the mortgage fraud. About the mortgage fraud, we can say that first of all, the information about the loan taker is very important. The institution who gave those kind of mortgage, like as bank, using the credit card or other resources, financial resources of the person, the robber usually provide the false information about the loan taker's income to borrow a larger sum of money. Machine learning for fraud detection in mortgage section can score bad borrowers based on the history of their transaction and find suspicious information in their documents in order to pass those cases to the bank professional for deeper validation. The other one is the document forgery. And document forgery is type of fraud often referred to as identity theft. The robber can forge or steal a victim document to use online for taking a loan or obtaining other illegal favor. Information on the document can be changed entirely or partially, depends on the criminal goal. Example of such changes include the date and place of the birth, in fact, home address, fake water tank, stamp, and adding pages to another document that is already exists. One of the top places to buy documents illegally is so-called uh, black market. Criminals tend to use an illegally obtained ID with someone else's photos or personal details to fool the system. If the system does not have a strong enough identity validation system to spot forgery and illegal activity, or doesn't have one at all, it becomes a very vulnerable to possible fraud attacks. Machine learning has many algorithms that work with image and can classify them as fraudulent or not be finding any specific feature and correlations. Additionally, there are some anti-spoofing methods that we can use to understand whether a document is the printed copy or its original, and recently it's used mostly by the governments in all over the world. Before going to the next slide, we can have a 5 minutes for resting, and we will come back in 5 minutes. In the rest of this workshop, first we have another speaker that talk mostly about the other method of machine learning and data science in Python, and he can help you to do it by yourself. And then after, I come back and talk about the types of machine learning and how we can use them. So see you in 5 minutes.
See you. Hello, everyone. This is Dr. Majid Wafa. I am a developer at Recom AI. I have experienced more than 20 years. Just let me know that I share the PowerPoint. Can you see?
Yes.
Yes, we can.
Great. In this section, I want to introduce about data science and why we are using the Python and what Python is the best. You know, the Python is as the basis for the specialization for several reasons. First, it's easy to learn. Python is now the language of choice for introducing university students for programming. It's used in 8 out of 10 of the US top computer science programs. Python programs tend to have minimal templating that you might have seen in other languages. So the templating is very important. If you have programming experience, but not Python specific experience, you can pick up Python very quickly. It's another feature. It's that it's very general programming language with lots of building libraries. So at manipulating data, network programming, and databases, that is very essential in data science. Another thing is its nature, and there's plenty of resources available from books to online courses that I'll introduce to you in this session. So Python is dynamically typed language. We don't have to declare the type of variable while assigning a value. As you know, in other languages like C, you need to declare the type. So we don't need in Python. Other languages like, you know, C, C++, Java, because there are lots of defining the type before writing the code. Finally, Python has a significant set of data science libraries that we can use. The base of this is called the SciPy, which is open source software for mathematics, science, and engineering. Other libraries are NumPy, Pandas, and Matplotlib as a part of the SciStack, and to provide an excellent basis for moving into machine learning, text mining, and network analysis. So for the data science outline, just broken into 4 models. The first one is focus on getting prerequisites in place and review some of the basics of the Python languages. The second one, we're going to dig into the Pandas toolkit and other that you can see. Generally, the Venn diagram is very important to detect, margins and how to define the data science, machine learning, and traditional research. This Venn diagram presented by Drew Conway, it shows that data science is made of 3 things. We can put them as overlapping circles because it's the intersection that's important. First one, hacking skills or coding computer skills. Math and statistics knowledge or quantitative abilities in general. The third is substantive expertise, which is familiarity with a particular field like business, science, or health, or something like that. So the intersection in the middle is data science. It's a combination of these 3 items. So hacking skills or coding computer skills, we can gather, prepare data. It can be very unusual formats, and it requires creativity to get the data from the source to put it into your analysis. Another is math and statistics knowledge that can be knowledge of probability, algebra, regression, and other things. This generally help us to choose the appropriate procedure for the data. The third, as you can see in the picture, is the expertise, which is familiarity with a particular field. You need to know about the goals of that field. And as I introduce you, it should be business or science or health. We need to know the constraint in that specific field. So machine learning is considered as coding and math without domain, and sometimes it's referred as a black box models. The traditional research, it could be math and domain without coding, because the data is highly structured and it's ready for analysis. And you can see for the danger zones, you know, that hacking skills and substantive expertise without having any knowledge about math and statistics. So we can have practice for Python. I just copy the link for you. You can practice together. It's a collab link, Google. Okay, just copy and paste in chat. Just share again the Google Colab. Now we can see the code. We can run together, but I'll describe here. Okay, so first we start with some simple rules for coding. It's defining the parameters. As I mentioned to you, we don't need the types. For example, here x1 and x2, just we define and we run and we have a result here. But the type will be inside of the variable. I'll show you that how we define the type. Another is defining the function. It's a simple function for add numbers. So here you can see that when we run, it gives us the values for plus 2.5 plus 3. Another one is defining defining the third parameter and how to define. So the third one, it will be optional. If we write the code like this, if z equals known, so x plus y, and in this case, else, when we run, you can see that if we define z, we have the new result. If not, but the program and doesn't give us the code error. Another one is defining the flag. If flag is true, it gives us flag is true, means that when we have the Z, we define a flag to how to know that there is a Z in this case. Generally, flags are very useful in the coding. So you need to define, for example, you define an alarm for a system, operation system, and you want to know that how you can define the flag. So it's very important. Another one is assign function to a variable. For example, here, the variable A, we assign the function A for that one. So it gives us the result with only writing A1 and 2. It will be easy to write the code here. As I mentioned, the type command is how to define the type of the variables. So in this case, this is a string, as you know, the type is str or a string. The known is non-type. The one, as you know, is integer. If we add float 1.0, it defines float, and finally the function. So we have several types. It's important how to work with all of them. Sometimes we need integer or string, and converting between these types are very important in coding. Another type of important is immutable data structure. In comparison with list, here we have it's mutable. It's it can be altered. Here, for example, it's we define 1A, 2B, and the type will be the structure is important how to define. For example, here you use a parenthesis, here a bracket, and the list will be created. They use both types, but the lists are more flexible. I'll describe for you how to use a list. For the list, we can use the append command. Append command add to the last object to the list. For example, here add the tree at the last object of this list. Another one is defining a loop. So if define an item is the print all the objects in the list. So defining the for and while, that the while is type of the loop, but it's using indexing operator. It iterates into the loop until the length of the x. So it's the same as for in this here. But in the different case, you can use how to define while or use or for. Another one is the concatenate list. Add or combine between two lists. You can use plus easily define between two lists. So if 1 or 2 plus 3 or 4, you can create a list with 4, index or objects. Also, you can use the multiply. It multiplies, for example, here 3 times. You can run for yourself or change the code if you want to practice how to define the code. Here, it's a kind of find option. It can use that, for example, find the number 2 in this list. If it's true, it means that it's correct. And if it's not in this list, it shows us false. Another important command for lists. So you can see that all these commands are for lists. So list is flexible how to use it. Another one is defining a string and how to manipulate data into the string. So we have string A, B, C, D, E. The X bracket 0, it shows the first character. 0 to 1 means the first character until 1, that's prints. It's the same as X0 here in this case, but 0 until 2, it means that 0 and 1. So print 0 and 1 character. So here it starts from 0, 1, and 2. Another one is X bracket -1. -1 shows the last param character here. The last one, it was A, B, C, D, E, and it shows E. Another one, it shows -4 until -2. It means it retains the fourth element from the end and stopping before the second element. So the fourth one is C, and the -3, it will be B. It doesn't print -2 because it's before -2. Then it's, blank, it shows all until the third one, the third element or character. In opposite, it will be third until the end of the, list. These are very useful in data science. Here we have, we wanted to know how to split and define work with strings. The first name is Super, last name Brooks, and when we add a space, it shows the name, family and name. When we multiply it applicable, and it copies 3 times. Chris search, as I mentioned to you, in is like as find, and how it searches into the string, and it shows true. Another useful command is split. How to, for example, here, the name has, for example, split. It shows that the split shows that it selects the first element until you have this character that here is a space. So the first one, search and find until here, because we have a space here. This is how to manipulate data in strings. Also here, because it's -1, it searches from the end of the string, so it will be Brooks. One of the errors that you can find sometimes is that using 2 different types of objects. So be careful about that. Here it's Chris is a string and 2 is integer. So you cannot concatenate between these 2. First, you need to change the integer to a string, then add them, and after that you can work with Chris 2. Another important, types of variables, it defines as a dictionaries. Dictionaries has keys with values. So the first one will be key here, and the second one is value. So here you can see X, Y, G, the key that gives us the values here. And you can iterate all of the keys or values. For example, here, print all the keys. The first element, you can add another element to the last dictionary, and also iterate over all of the values. Just define X point values. With X point items, you can iterate all over the keys and values together. So it prints the keys, first keys and values key and together. So this is another item. It's important to, print the list. When you have different variables, you can, unpack with different names. For example, Christopher Brooks and one email. When you define first name, last name, email, it detects that the first one is Christopher, the second one is Brooks. But be careful that here we show that it matches the number of variables. For example, here if there is 3 variables, the sequence should be in 3. If there is, for example, 4, it gives us an error, as you can see here. Here is a general practice for reading CSV file, and we want to define several cars, and there are several questions how to define miles per gallon for each car, how to classify the cars. For example, you know that based on different consumption in fuel or, for example, models of cars and type of transmission. Just summarize and then come back again to the PowerPoint. This is the file that first you need to run for yourself. It's 234 cars. As you can see, the keys gives us all the keys for the file in this CSV file. As an example, I show you this one is how to find the average city fuel economy across all cars. So it's search city Y means that the car the consumption in the city. It's iterate all of them based on the MPG and divided by lengths. So it gives us just an average consumption in the city. And also we have it in for the highway calculation. These are examples that you can. And now I come back again to the PowerPoint to cover all the materials. Okay. About Pandas, in this part, we're going to teach you the excellent Pandas library, which is related to data manipulation. And data, generally, you know that the data manipulation is really the foundation of what you'll do as a data scientist. And that doesn't really change, even as you deepen a lot of your investigation and your skills in the area. So Pandas was created by Wes McKinney in 2008. It's an open source project under permissive license, so you can use it easily. This open source project, it has a strong community. It's very important, with more than 100 software developers committing code to help make it better. So if you have any question, you can ask them. To be more engaged with this tool, you have to use the answering and the questions like as Stack Overflow that I'll introduce to you. Stack Overflow is used broadly within the software development community to post questions about programming, programming languages, and programming toolkits. The Pandas community in particular uses as their number one resource for helping new members. It's quite possible, that if you post a question to Stack Overflow and tag it as being Pandas and the Python related, that the Pandas developer will respond to your question. So it's very useful to use how to use the Stack Overflow. It will accelerate to be familiar with code and you can solve your code issues. So it's a great place to see what issues you have, and a second resource you want to consider are books. I just want to introduce 2 books for you in this session. 2012, Wes McKinney wrote the definitive Pandas reference book called Python for Data Analysis and published by O'Reilly. This was updated in 2017 to the 2nd edition. This textbook is an important resource in understanding how Pandas works. Another brief book is Learning the Pandas Library by Matt Harrison. It's not a comprehensive book on data analysis and statistics, but if you just want to learn the basics of Pandas and want to do it quickly, I think it will be great. So about Pandas data structure, after that, we'll have the data collab and we will work together. First, this series object is, this page gives a summary of Panda data structures. We're going to talk about querying data frames. The first step in the process is to understand Boolean masking. So a Boolean masking is the heart of first and efficient querying and both NumPy and Pandas. The goal is to understand how Boolean masking works and how to apply this to a data frame to get out the data that you are interested in. Now a Boolean mask is an array which can be thought as a 1 dimension like a series or 2 dimension like a data frame, where each of the values of the array are either true or false. About iLook and look, I'll describe it later, but just as a, I wanted to tell you that iLook is querying based on the position, gives you position of data frame, and look gives is a rows based and gives you the labels. So here it's the series structure. The goal is to be familiar with how to store and manipulate single dimensional index data in the series object. The series is one of the core data structures in Pandas. You can think of it as a cross between a list and a dictionary. That I introduced you about list and dictionary before. The items are all stored in an order, and there is labels with which you can retrieve them. An easy way to visualize this is 2 columns of data. The first is the special index, like a lot of keys in a dictionary. And the second is your actual data. So it's the same as between dictionary and list, but it's useful in data science. About data frame structure is heart of the Pandas library. Data frame is conceptually, a 2-dimensional series object where there is an index and multiple columns of content, with each column having a label. In fact, the distinction between a column and a row is only a conceptual distinction. And you can think of the data frame itself as simply a 2-axis labeled array. Similar to the series, you can extract data using the iLook and look attributes. As the data frame is two-dimensional, passing a single value to look indexing operator, so the result will be one row to return. In the picture, you can see the example. So in iLook2, it gives us the tiger and Bob. If we define iLook5, but you know the column is we know the values, it's animal. It gives us the value here, and for the defining the look also we have the example. It shows there. So generally it's index and keys, same as index and keys, but it's two-dimensional. So in this picture, it tries to show, you know, visualize it, but you know, it's not easy to visualize this two frame. As I mentioned to you, for the setting data in Pandas, to add new data, just we define a df column, for example, A, B, and C. So the new data will be added. To set the defaulted or overwrite the data, we define the df column, for example, equal to. So it gives us all values for that column to change just to 2. Let's practice together for another Google Colab. So I share again the Google Colab. Same, I copy and paste into chat. We can practice together. Now I share the screen. As you can see here, first we started series, the data structure. First, we need to import Pandas. So we define numbers 1, 2, and 3. As I mentioned to you, it defines the keys and value. It's 0, 1, 2. It's the starts, and also it shows the type is integer. Another example that it can cover the object. We have also we can define as a float. So same as the types that we had in the general coding in Python, in the Pandas we have approximately the same type, you know, integer, float, you know, object, string. So if you are familiar with general coding, you can understand that. Another important issue is that I need to clarify it's how to define none, you know. So NumPy allows us to generate a none value. So we will import NumPy as a NP, and let's compare it to none. So just NP point none, does it equal to none? it turns out that you actually can't even do an equality test of none to itself. When you do, the answers always false, as you can see. So if we just do np.none equals np.none, we also get false. Instead, you need to use the special functions to test for the presence of not a number, such as the NumPy library is none. So we can use np is none. Here you can see. And we see that the result is true. So keep it in mind that when you see a none, N-A-N, its meaning is similar to N-O-N-E, none. But it's a numeric value and treated differently for efficiency reasons. So N-O-N-E and N-A-N is different in this, Pandas.
We lost the sound.
This is an example for a series. While my list might be, a common way to create some play data, often you've labeled data that you want to manipulate. A series can be created directly from a dictionary data. As I mentioned to you, it's very close to each other. So if you do this, the index is automatically assigned to the case of the dictionary that you've provided and not just incrementing integers. So I just want to check that. I just wanted to be sure that someone wrote. It's fine now? Okay, great. Thank you, guys. So about this one, if you are using from directly from dictionary, it creates the values. So if not, we need to define the index and object together. Just want to describe a little about querying a series. So Pandas tries to make our code a bit more readable and provides a sort of a smart syntax using the indexing operator directly on the series itself. So here, as you can see that we define an example with the iLoc tree, it shows South Korea as we expected because it starts from 0, 1, 2, and 3. It shows iLoc. And loc here, we need to define the index value, and it's Japan. And if we define directly as bracket 3, it's the same as iLoc here in our case. This is an example that we define the index by ourselves. So it's 99. So if you define S bracket 0, it gives us error. As we expected, we don't have any 0 here. So you can practice. These are very useful example. For example, defining loop, you can create the random. It's in this example, if you wanna compare between the speed between using NumPy and general coding in Python. So the comparison, I just show you the results to understand. Here it's the results. You know that it takes 1.46 millisecond per loop, but here it's 47.2. It's a some example for using normally plus value or using some value from NumPy. But here you can see it takes 72.8 microseconds. So it, it's very fast using NumPy. This for example, just want to show the split between these two libraries. I just want to pause until I want to continue to the PowerPoint. 1 minute, I just want to share again the PowerPoint. I think I disconnected. I just want to share again. Can you see my screen? Please confirm it.
Yes, we can see it.
Yes.
Okay. Sorry for I lost the connection. Okay. I told you about the distribution, probability distribution is very important for data scientists. And how to create a random variable. You know that in statistics, there are several defined probability distributions that have different shapes and can be used to model different types of random events. In this slide, you can see, for example, uniform distribution, normal, chi-squared, and binomial distribution. First, let's start with uniform distribution. It's a type of distribution where all outcomes are equally likely. So each variable has the same probability that it will be the outcome. As an example, a deck of cards, has within its uniform distributions, because the probability that a heart or club, diamond or a spade is pooled is the same. Another example is the coin that has a uniform distribution, because the probability of either the head or the tail in the coin toss is the same. The density plot of the uniform distribution, it appears flat because no value is any more likely than another. Many useful functions for working with the probability distributions in Python are contained in SciPy.stats library, so you can find it there. At the heart of the statistics lies the normal distribution, known to millions of people as a bell-shaped curve. It's a two-parameter family of curves that represent lots of probability density functions. Mu is the mathematical mean. In this case, it shows that data near the mean are more frequent and are in occurrence than data far from the mean. Sigma, it means a standard variation. Another interesting detail of this distribution is when we calculate the standard deviation. We find out about, for example, 68% of the value are within first standard value deviation of the mean. 95, it will be 2 standard deviation, and there's another example, it's 99.7, it's within third or 3 times the standard deviation of the mean. Chi or squared is the distribution of sum of the squares of k independent standard normal random variables. So the chi-squared distribution is a special case of the gamma distribution. Generally, in the gamma distribution, the degrees of freedom is an estimate, is the number of independent pieces of information that go into the estimate. For example, to estimate the population variance, one must first estimate the population mean. Therefore, if the estimate of the variance is based on n observations, there are n-1 degrees of freedom. So application will be, for example, the distribution of categorical variable in a sample often needs to be compared with the distribution of categorical variable in another sample. Like in some health science, it can be used. The last one is binomial distribution. Is a discrete probability distribution that models are outcome of a given number of random trails of some experiment or event. A binomial distribution can be thought as simply the probability of a success or failure outcome. So this is the reason it's discrete. So the outcome is success or failure. And it should be, for example, repeated multiple times. Is a type of this distribution that has 2 possible outcomes. So I covered all the material for the data science. We can have the 5-minute pause until the Dr. Neda Navidi joins us and continue for the second section of machine learning. Thank you for your times for this section.
Are you mute?
Hello, everyone. Hello again. Welcome to the second section of this workshop. Okay, as I want to continue this workshop, I want to talk about the type of machine learning. And it's really important to understand and get those kind of concepts very well. Well, in fact, we have 3 main field of machine learning, 3 main classes of machine learning. The first one is the supervised learning. The second one is the unsupervised learning, and the last one is the reinforcement learning. About the supervised learning that mostly used for the data scientists, mostly used in data analyzing and in lots of fields. Well, in fact, we have lots of data. Those data are labeled and they are annotated very well. And we can see there are lots of columns with a specific label or tagged on them. So we have
we have lots of data gathered together, and we name them as a data set. In using of those data sets, we can use them, part of them for the training and part of them for the prediction and test. And with using the training part of the data, we can create a model. When we create a model, this model can be used for prediction of the unseen data. Those kind of information are very useful to have information about the future event impact. The second category of the machine learning is unsupervised learning, mostly using in anomaly detection or even fraud detection. In anomaly detection or in unsupervised learning, it's happened when we have a huge bunch of data. There are lots of data, however, there are not any tag or label on them. So what's happening here is we have to somehow dealing with those kind of data, but we don't have any tag on them. And because we don't have tag on them, I cannot really create a model with them. So what we can do, we can try to cluster those kind of information. It means that we trying to, using different kind of algorithm, trying to create different cluster of those information. And in each cluster, most of the characteristics of the data are really, really close together. It means that we cannot say exactly those kind of information are in a same class. However, we can see that their characteristics are very similar together. And the last, give me a moment, please. Okay, and the last class of machine learning is reinforcement learning. Reinforcement learning is about, it's a class of machine learning that we don't have any kind of data, not at all. We don't have any data, zero data, and we're trying to create a model. So what's happening here is we have an agent, an environment, and those environment and agent dealing together, trying to create different kind of scenario. And then after with using with the punishment and reward, we can tag them. So some kind of classify as a good examples or bad example. And at the end, we can train a model with those self-created data. This is the reinforcement learning. Reinforcement learning mostly used in any kind of superhuman AI, super sophisticated algorithm, like as the self-driving like as self-driving, autonomous car, autonomous driving, self-drone patrolling. It means that the car or drone can move inside their environment or fly in the environment and gather more information from their environment. And then after with using those information, they can create a new model and use those models for the unseen event. Also, we have some other machine learning type that it's recently is really interesting and very useful. For example, one of them is the semi-supervised learning that use the supervised and unsupervised learning together. When we're talking about the semi-supervised learning, it means that we have two types of data. Part of the data is the labeled and there are tagged, but they are a small data set. The other part of the data are huge data, but they are not labeled. So what we're doing, it's like as we're using the unsupervised learning for clustering the data. And after that, we're using the supervised learning we can annotate or tag those cluster. This is the semi-supervised learning. The other class of machine learning that needs very great recently, it's the imitation learning. Imitation learning is a class of learning between the supervised learning and reinforcement learning. What that means, it means supervised learning trying to train a model from zero, from totally scratch. We don't have any information and it's trying to create a model. So it's really hungry for data. We need lots of data. So the training the model would be super costly. If we can create kind of the data, any kind of data, we can create them and feed them to the model, the reinforcement learning would be more faster. So this is the imitation learning. In imitation learning, it's mostly like as there is kind of a connection between a teacher and a student. And it means that a student mimicking a teacher, and by mimicking a teacher, it can learn more faster. This is the concept of imitation learning, that it's using the supervised learning and reinforcement learning together. In the next slides, I will more explain them. And if you have any question about it, please let me know. It's really important you get the idea of those class of machine learning. And if you have any question, any problem to understand something, or any kind of misunderstanding, please let me know about it. Okay. Well, machine learning tasks, including the one I've described as an example, examples like as credit card fraud detection, movie recommendation, speech recognition, and so on, can be categorized in two main types. The first one is the supervised learning. And here our goal is to predict some output variable that's associated with each input item. So if output is a category of a finite number of possible, such as fraudulent or not fraudulent, yes or no, good or bad, something like that, those kind of prediction for a credit card transaction, we call it as a classification problem. Classification problem related to the supervised learning. So whenever we're talking about the classification problem, we're really talking about the supervised learning. And the function that we learn is called the classifier. Sometimes even we name it as a model, classifier, when we're talking about the classification or supervised learning. If the output variable we wanna predict is not a category, but it's a real value number, like as the amount of the time in seconds it would likely take a car to accelerate from 0 to 100 kilometers per hour, we call it as a regression problem. And we're learning something called regression function. So whenever we're talking about the supervised learning, we refer to a classification problem or regression problem. If we can really classify the classes like as yes or no, apple or orange, or any kind of classification, it would using the classifier, and it's the classification problem. And if it's tied with the real value, but not a class, it would be the regression problem with the regression function. More formally, we typically denote a table of data items using the capital letter X, and there's one data item per row, as you can see. For example, here, you can see we have apple or banana. And for each sample, we consider that one as the X, X1. This is the first apple. X2, for example, is the first banana. X3 is the second apple. X4 is the second banana. And X5 is the last apple. And X6 is the last banana. And so we have two columns of data tagged with each one is the X1. And the class of this example is tagged with apple or banana. So we have different apple tagged with apple, different banana tagged with banana, and the tag value we mentioned as Y1 or Y2, as you can see here. And so as I said, the goal is to learn some function that map data item in X to a label in Y. And to do this, the systems give a set of label training example of input X, subtitle I, and output Y, sub I. And this set of label training example is what's used to identify the function that best maps the input to the desired output. Okay, so for example, if the supervised learning problem is image recognition, this involves building a classifier where the input X sub I could be a set of pixels that describe a signal of a single image, in fact. And the desired label Y sub I might be the label of the object of that image. For example, think that you have an image with a face of with a picture of the face on that. So the pixel number would be X sub I, and the tag that it's the object on that image, that is the face, would be Y. Now there are many algorithms that scientists have developed that can do supervised learning, that could be used to estimate the function f from the training data, and we'll cover a number of those algorithms in this workshop. Supervised learning needs to have this training set with label object in order to make its prediction. The question here is, if the whole point is to predict these labels, where does this initial data set or label item come from? Mostly this question is about data gathering. Data gathering in supervised learning is the main issue, the main factor. It means no data, no model. The answer is that the training labels are typically provided by human judges. There are mostly no reliable automation for the labeling or tagging in supervised learning. There are some kind of method or even application, however, is not enough reliable to use for creating another model. Now, obtaining the label for some problem can be easy or difficult, depends on how much label data is needed. The level of human expertise or expert knowledge that is needed to provide an accurate label And the complexity of the labeling task, that task are also other factor. Now the use of some kind of crowdsourcing platform, like as Amazon Mechanical Turk, have been a significant source of explicitly provided label from human workers. Mechanical Turk is a website where customers with machine learning tasks that needs labeling can connect with group of workers that can provide labels using human intelligence. So those are more explicitly obtained labels. We can also obtain implicit labels. So for example, if a search engine detects a user clicking on a result link and then sees no more activity for another minute or before the user comes back to the search engine, the system might use that activity as kind of an implicit label for that page. On the other word, if the user took some time to visit the page, it was more likely that that page was relevant to that query. The second major class of the machine learning algorithm is called unsupervised learning. And in many cases, we only have input data and we don't have any label or goal data to go to deal with those kind of data. And in those cases, the problem we can solve involve taking the input data and trying to find some kind of useful structure on them. Now, what do I mean by structure? Okay, let me explain. Well, typically, this means finding interesting cluster or group inside the data. So once we can discover this structure in the form of cluster, groups, or other interesting subset, that structure can be used for tasks like producing a useful summary of the input data, maybe with visualizing the structure. For example, you run an e-commerce site that sells products to customers. Let's suppose you got many thousand or even million of customers. You might want to know if you can categorize or group the customer into different types. As you can see here, for example, the group of careful researcher, power user, or quick browser. For example, there might be power user who use more advanced feature of the site. There might be quick browser type user who only look for a cheap discount and stay for a very little time on the site itself. Also, there could be sort of careful researcher type user who spend a lot of time comparing different items. If you could take your time of how people interact with the site and use unsupervised learning to discover these different groups, you can figure it out and then maybe tailoring your site offering to each group. So the chance that a user from that group might be purchase the product, it's getting high. Now you don't know how many groups they are out there ahead of time, or even what they look like. And we don't have any label examples. And so this is a classic example of unsupervised learning problem. Another type of unsupervised learning problem that is very important is something like flagging abnormal access to a website. So for security reason, you might want to be notified if a website user is making requests that could be a cyber attack, or is somehow very different from typical user behavior on your website. Since there can be many different types of hacking or intrusion attempt to break in a server, we don't have reliable training label that we could use to train a classifier using the supervised learning. Instead, we need unsupervised approach that allow us to perform something called outlier detection. That doesn't assume future attacks will be the same form as previous attack, but that does assume feature of the attack of that site will look different somehow than the average user behavior. Okay, suppose you have a situation where you think machine learning might be applicable either using supervised or unsupervised approach. How would you apply machine learning to solve a problem? Any idea? Okay. Well, there are three basic steps that I'm going to use classification as my typical machine learning scenario. So I'm often just use the term classifier as an example of the machine learning task. The first one is how we present a data. The second thing need to do is decide on an evaluation method that provides some type of quality or accuracy score. Once we've decided on how to represent the input data, the type of classifier or evaluation method, we need to then search for the optimal classifier that gives the best evaluation outcome for that problem. And I explain it through this workshop. Okay. So the first problem in solving a problem with machine learning is you have to figure it out how to represent the learning problem in terms of something that computer can understand it. You need to be able to take your data in a way that you can use as input to an algorithm. And you also need to decide what type of learning algorithm to apply to this data. For example, there are many different ways you would represent an image. Typically, it's represented as an array of colored pixels. The second also be metadata associated with the image. You can think about how you might represent a credit card transaction if you wanna do fraud detection. So that might be represented by time, the place, and amount of transaction. So you need some way to represent of the data you have and the choices of what kind of algorithm you want to apply to that image. As you can see, in this 3 examples here, we have the first one is based on the email, and there are kind of information in this email. For example, the sender, the receiver, the subject, and the whole email information. So the feature here would be So the feature here, as you can see, it's to Chris, Brooks, from Daniel, Romero, and Deb. So as you can see, when we're dealing with the email structure, the feature are the word. And as you can see here, there are kind of natural language processing dealing with the word by word, analyzing the email. That is out of the scope of this presentation. However, we extract the feature by that. So as you can see, when we're dealing with the email and NLP related application, a list of words with their frequency counts would be their feature representation. Where we're dealing with image or video, first I should mention that when we're talking about the video processing, it's like as the image. The only difference is that the whole process is the same. The only problem is that in video, we have lots of image or lots of frames that create that video. And analyzing that would be a bit harder, more time consuming and costly. And mostly we have to dealing with a specific type of neural network named DNN or recurrent neural network because it's much complicated. Anyway, when we're talking about the picture, the matrix of the color value would be the extracted feature of that image. The last one is the specific C creature, like has different kind. Think about we have different type of C creatures, and for that one, we have a big table with like has their weight, their color, their size, or the other kind of information. So a set of attributes values are the representative information for those kind of application. Okay. About the machine learning feature representation example, the other example here I wanted to talk about it. It's something here we have. It has when we're dealing with the data set that there are lots different of the fruits inside, like as an orange, apple, banana, different kind of image. We can consider different feature like as the height or mass or color of those images, samples, and we can create a table. And inside the table, as you can see, we have the label part that is related to the name of that fruit. And the feature representation is related to the different kind of information we can extract from those specific fruit. Then after, with using those features that we extracted, we can use different kind of machine learning algorithm, like as KNN or the other kind of machine learning algorithm, different kind of classifier, in fact, we can train a model. As soon as we train the model and the model is ready, we can use unseen fruit that, for example, we don't know what it is, and we can predict the class, that it's the apple or banana or orange or any other fruits, for example. Now, in the previous session, Dr. Majid Babaha talked about some machine learning needs in Python and talk about it. And I wanted to present the machine learning in JavaScript. You will see that there are lots of libraries using the machine learning in JavaScript, not in Python. Most of these libraries has the same version in Python. So if you're a Python user or JavaScript user or C user, you can easily find the same parallel one in your favorite language, in fact. And why I want to talk about the JavaScript, JavaScript in machine learning. Well, in fact, the JavaScript needs no special introduction. It's one of the most popular cross-platform language among the web developers. And while some people consider it only a language for front-end development, JavaScript acts as an all-purpose programming language nowadays. And its possibility are endless. Looking for the top JavaScript library that you can use in your machine learning project could be really interesting for you. Okay. The first machine learning based architecture in JavaScript is the Synaptic. Synaptic is well known as a JavaScript neural network library created by MIT that can be used with Node.js or other browser. One significant feature of this library is its ability to build and train any first order or second order neural network architecture due to its architecture-free algorithm and pre-manufactured structure. It can also import or export networks to JSON as a standalone function so that they can connect with other network or even gate connection. Synaptic includes some interesting building architecture, like Hope field network, state machine, multi-layer perceptron line, and short-term memory network or LSTM. And LSTM, as I said before, is kind of the RNN, recurrent neural network related to deep learning. Because Synaptic is an open source library, anyone can contribute to it or use it for free. Synaptic also includes a trainer that is capable of training any specific neural network with tasks like embedded grammar tests or solving an XOR or completing a distracted recall task or built-in training task. It's also helped in comparing the performance of different neural network architecture easily. This is just an example of Synaptic library, and you can work on testing the process of the neural network that it's created above. It's so easy to apply. As you can see easily, you can create your layer and then after create a model. So it's much easier to deal with those kind of ready to use library. And because it's the JavaScript based, you can easily download it and use it on your browser. The next one is the Brown.js, that is the JavaScript-based fast-running library used for the machine learning and neural networking. It can be used in the browser or with Node.js. With the Brain, different type of neural network are available for different tasks. It provided support for various neural network like as LSTM, recurrent neural network, and feed-forward neural network, mostly related to the video processing. It's a fast processing library because of the use of the GPU for computation. Even if the GPU is not available, it reverts back to pure JSON and continue to process. Brain provides multiple neural network implementation and encourages building, training, and running those neural networks on the server side aligned with the Node.js. Another good thing about this library is that you don't have to be strictly familiar with neural network to work with it. In order to integrate your website with the network model, you just have to implement them as a function or use JSON format. The Brain can be used to create a simple neural network quickly using a high-level language. It's allow you to build some really interesting functionality with just a few lines of code and good data set. Furthermore, Brain provides the capability to run on client-side JavaScript. The next one is the TensorFlow. If you're a Python user, probably you heard about it because it's the parallel one in the Python, and it's the open source JavaScript library built by Google Brain. Gathering, it provided hardware acceleration with a complete and flexible variety of tools due to its deep learning layer and comprehensive linear algebra. This library had become the bread and butter of all JavaScript projects based on machine learning. Tensorflow Js allows users to train neural network with the help of a browser or execute pre-trained model in an inference model while bringing up machine learning building blocks into a web. You can run the default TensorFlow model that can currently available or even convert them into some Python model as an additional. Furthermore, TensorFlow JS makes it super easy to build models from scratch using the low-level linear algebra of JavaScript. TensorFlow JS also includes some pre-existing machine learning model. They can be used to retrain your own data. It's also provide the capability to deploy the machine learning model anywhere, including the device, regardless of the language you use, the browser or the cloud. You can consider using TensorFlow JS for your next machine learning based JavaScript. It provides better computational graph visualization while also offering some benefits such as frequent new releases, quick update, and seamless preferences. Besides, TensorFlow is highly parallel and built to be used in combination with numerous backend software like as ASIC or GPU. And the other important things about this version of TensorFlow, including many other subversions such as TensorFlow Extended for the full experience, TensorFlow Lite for mobile, for example, TensorFlow Rust for Rust binding or the other applications. The other library that is used for the JavaScript is mine, is absolutely flexible library for neural network and dealing with browsers and Node.js to make better prediction. One of the key features of mine is that it process training data using a matrix implementation while allowing developer to customize the network topology. Getting started with this library is very convenient and it's quickly pluggable and easier to download and upload plugs than other libraries. The ease of configuring pre-trained network is also another important things about the mine. The other library is the Concatenate.js that is specifically designed for training deep learning model and working with neural network. The most important feature of this library is that it totally depends on browser, so any other special software like GPU compiler are not required at all. Concatenate also support Node.js, and Concatenate consists of common neural network module that have fully connected layer and non-linearities. This library processes the ability to formulate and solve neural network using even simple JavaScript while offering the support of some common network module. It also offers features of specifying neural network, classifying and regret problem, convolutional neural network for image and video processing, and experimental reinforcement learning module based on deep Q learning, and a supplementary learning module that's still an experiment in an experimental level. Refer to the following simple code you can see here. You can see that how to implement the concatenate in neural network is so easy and so fast. So as you can see, you're just training the model, and then after the model, as soon as it's ready, you can use them for browser-based prediction one. The other one is the ML5, that is a fully packed, comprehensive open source library for machine learning with Node.js and browser, and you may add your own dependency with using the Node.js. It builds based on the TensorFlow and doesn't have any external dependencies. Similar to TensorFlow, this library can handle mathematical operations that are accelerated by GPU apart from managing memory for machine learning algorithm. ML5 make it easy to access many pre-trained machine learning algorithm in the browser. So that it can be used for various purposes. The purposes like as detecting human body language or customizing image or generating text or finding language relationship. This is library, well, in fact, it's kind of library that's empowered to provide an intensive understanding of machine learning aligned with various complexities such as ethical computing and data collection, making it suitable even for beginner. ML5 also offered using for unsupervised and supervised learning problem and mission critical and a straightforward model. Furthermore, it's an all-in-one general-purpose JavaScript machine learning library for JavaScript developer that includes supporting library for mathematics and statistic, regression algorithm, AI network, unsupervised and supervised learning, feature extraction, and lots of other applications. This is about ML. The next one is the Nero. That's the for developing and training reinforcement learning model and deep learning model. It's not really for the beginner. It's mostly for advanced or intermediate user. Because mostly dealing with reinforcement learning and deep learning used in making assistant with AI technology and chatbots. Many developers use this library to develop, practice, and train deep learning and machine learning model, then deploy them in a web browser or on Node.js. Some of the main advantage of this library are that it helps to engage in real-time classification, provide the online support for learning, and support the classification of a multi-label form when creating machine learning project. The next one that it's so famous for the also Python user is the Cross.js, because it has a parallel one in the Python, and you can consider it as a second most widely used JS framework for deep learning after TensorFlow. It's very popular among the developers who work with neural network libraries, as several frameworks are used by the Cross. For backend, you can train model in CNTK or TensorFlow or other framework. The machine learning model built using the Cross can be run in a browser, although model can be run in Node.js, only GPU mode will be available for that. This is the last library I wanted to talk about it. And if you, okay. Since the TensorFlow launched in 2018 for the JavaScript user, there are lots of adoption by the JavaScript community with 2 million downloads of this application. Meanwhile, it's the distinctive class of machine learning application. that merge that leverage of unique advantage of one device computation. And in this title, I discuss how to use the TensorFlow high performance machine learning for developer and talk about it, how it would be. I'm trying to finalize it in 5 minutes, and then after we have a session for your questions. Okay. Earlier this year, Google released its first ever AI-powered Google Doodle, in which user could synthesize batch-style harmony using an ML model running in a browser. In just 3 days, more than 15 million people used it to create, save, and share their music. A creative marketing team in Google has built a fun, interactive experience where users are shown a zodiac symbol, and they try to match the shown animal with their hand shown, making the characters come to life. Other teams are experienced with way of making a web interface more accessible. In this example here called Creatability, people can control web application with gesture, such as playing keyboard with their face motion, as you can see here. Meanwhile, a distinctive class of machine learning application has emerged that leverage the unique advantage of one device computation. All of this has been made possibly by TensorFlow, which is the open source library of machine learning in JavaScript, and it can be used for the browser or server side. It allows you to do machine learning in browser client side, which means you can lower latency, higher privacy, and lower servicing cost of course. And we also know that it can support other environments such as Node.js, which means it can execute in a whole bunch of places. TensorFlow Js define the API for neural network applications such as matrix multiplication. These operation call it into kernel, which implement the mathematical function comprising the operation for particular extension environment. And in fact, if we look at this slide, you can see all the environment it can run. And the reason I bring this up, it's because when we're defining a web standard, often these things trickle into those other environments as well. So we've got all the common web browser there, but also Node.js on the backend, React Native for mobile and native application. And this is about for those of you who are not familiar with this architecture, this is the current stack right now. It have a bunch of pre-made model in the TensorFlow, and a very top there are super easy to use JavaScript classes, but just below this, we have a layers API, which is the high-level API to allow you do machine learning more easily, which is very similar to Keras in Python if you're familiar with Python. Below that, we have the OPS API, which is the more mathematical layer, so allow you to do these things like linear algebra. And this can talk different environment, like as the client side. Now, if you just focus on the client side for a second, you can see things like browsers, React Native, and we can see how to talk to the different backend, like as WebGL or WebAssembly. Now, of course, that the GPU is always available, but it's slowest of the execution. If a graphical card is available, you can leverage WebGL to get a higher performance on the graphics card, or if WebAssembly is available, we can leverage the high performance of the CPU by utilizing the low-level instructions. And before finalizing this presentation, I want to talk about, I'd like to provide an overview on how they compare in the most of performances. This table shows how the WebGL, WebAssembly, and Plain.js backend compare when it comes to interface on the mobile net medium-sized model with a few 100 million multiplications. For this model, the WebAssembly backend is between 3 to 11 times faster than the Plain.js backend. And also the WebAssembly backend is between 8 to 5 times slower than the WebGL backend. Okay, it's the end of this presentation. Anyway, because these days the machine learning and data scientists are very, very high demanding in most of North American and European countries. For anyone who are interested in those fields or changing their field and find a new job or new role in this path, I suggesting you to trying to doing self-study using different kind of courses. If you wanna follow your I don't know, bachelor degree or master degree in this field, right now there are lots of related field in different kind of university. I'm writing down my email address here. So anyone, if you have any question, please let me know. If you need any consultant about your changing your path from your current job to the other job related to the machine learning, I'm really open to help you guys. And so if there is any question, it would be the end of this workshop. I already did write down the email address. So don't hesitate to reach me out and talking your any issue about the machine learning, AI, and these related fields.
Can I share your email on Umbrella for those that are not here and may have a question later?
Yes.
Okay, thank you.
Thank you.
So I think that's it. We don't have any questions. So Neda, in the name of PTH Conference, I want to thank you for being able to be with us. Thank you
so much for having me.
Thank you very much. I hope we can meet again, maybe next year.
Maybe. Hope so. Bye-bye.
Bye. Thank you very much.
Bye. Thank you.
Bye.